Hi students, this is Nitya Priya. Even today we are going to see process scheduling algorithms. We already saw process scheduling and we saw the different types of process scheduling algorithms in brief. Okay, briefly I said what is first come first serve, what is shortest job first and all, round robin, everything we saw in brief. Shortly we have seen. Now in this particular topic we are going to see each and every concept, each and every scheduling algorithm in detail with examples. And these are the contents. First we see the scheduling algorithms. Then we see what is about non-preemptive and preemptive scheduling. Then we see first come first serve, then shortest job first, then priority based scheduling, shortest remaining time scheduling, round robin, then multi-level queues scheduling. So these are the scheduling algorithms. And you know what is process scheduling? Process scheduling is multiple processes when multiple processes are waiting for a single processor CPU, operating system will just schedule the waiting processes. Okay, so it just decides or determines which should be executed first, which process should be executed the second, which is the last, and so on. Okay, so all these scheduling concepts are known as process scheduling, which is done by the operating system. For doing process scheduling, operating system follows different strategies. We can call them as algorithms. Okay, and these are the different scheduling algorithms. FCFS, first come first serve, then shortest job first or shortest job next. Anyway, we can say priority scheduling, then shortest remaining time, round robin, multi-level queue scheduling, and so on. Now it is non-preemptive and preemptive scheduling. We studied about these two things, non-preemptive and preemptive scheduling. But here we see what is about that. What is non-preemptive and what is preemptive. Non-preemptive algorithms are designed such that when a process enters the running state, it cannot be preempted. Okay, when a process is currently running, when another process, even though which high priority comes, the current process cannot be completed, it cannot be removed from the processor until it completes its execution. So that is called as non-preemptive algorithm. So we need to wait for the current process to run completely, then only we can allocate the next process in. Okay, so the opposite is preemptive algorithms. Preemptive algorithms is the scheduler may preempt a low priority running process anytime, even if it is not completed. Okay, the currently running process, even in the middle of execution, it can be removed removed to the disk, and the higher priority process can be taken in. So this is called as preemptive scheduling. I hope you understand. And this is the first type of process scheduling algorithm. So I'll just run because it takes time when I say everything in detail, and the video will be lengthy. So please rewind the video and understand. Okay, I'll just move fast. The first type of algorithm is first come first serve. This is in the same order the processes arrive, the same order it is executed. Okay, so the process arriving order is P0, P1, P2 and P3. In the same order they are executed. See the table on the right side. The arrival times of P0 to P3 are 0, 1, 2, 3 respectively, and the execution time of those processes will be 5, 3, 8, 6. Why I am telling this is the same example we are going to have for all the types of algorithms, right? So these are the execution times of the processes and the service time. See, P0 is arriving the first. So when P0 arrives, no other process will be. So that will be taken the first. So the service time of P0 is 0. With no time it will be taken. When it comes, P0 comes, immediately it will be taken. Okay. So the service time is 0. Right. And what about P1? The execution time of P0 is 5. So only after P0 is over, P1 will be taken. So the service time of P1 is 5. Okay. See P2 service time is 8. What about 8? Because P0 service time is 5 and P1's execution time is 3. P0 and P1 is 5 and 3. So after 0 and 1 are completed, 2 will be taken. So 5 plus 3, 8. So at the time 8, P2 will be taken. So service time of P2 is 8. Then P3. You add everything. 5, 3, 8. So it is 16. So on 16th time, P3 will be executed. That is the fourth process will be executed. So the way the process comes, the same way it is, they are executed. So this is called as first come first serve. This can be otherwise called as first in first serve queue. And the operating diagram is shown on the below. See, these are the execution times. P0 is of 5 minutes, so it's 5. Then P1 is of 3, it is 3. P2 is of 8, so it is 8. And I hope you understand, right? So the next type of algorithm is first come first serve. The first come first serve. Here we just count the waiting time of the processes. Waiting time is just calculated by service time minus arrival time. Okay, so see here, 0 minus 0 for the first one. Service time minus arrival time is 0 minus 0. For P1 this is 5 minus 1. Okay, for P2 it is 8 minus 2. And for P3 it is 16 minus 3. Okay, so that way it is calculated. See, so for calculating the average waiting time, we add all the waiting times divided by 4, because there are 4 processes. We divide by 4 to take up the average of waiting time, right? So it comes around 5.75, right? Keep this in your mind. And this is the second scheduling algorithm. It is shortest job first. Even though number of processes are waiting, the shortest process will be taken the first. The motto of this type of algorithm is to reduce the waiting time of processes. The shortest job will be quickly finished, okay, so that the other processes may be quickly executed. So in order to reduce the waiting time, this shortest job first algorithm is designed. Okay, so but this is possible only when the length of the jobs or the burst time of the jobs or the process are known. Okay, only when the burst time is known, we can schedule this shortest job first effectively. If the burst time is not known, or if the length of the job is not known, this is not possible, and when it is implemented, even then it will be a failure, right? So that is called shortest job first. The same example we have. When we implement shortest job first, what happens? No, see here, P0, service time of P0 is 0, because when the time at P0 is entering, no other process will be, so that will be serviced first. So service time is 0. So when P1 comes, see, when P0 is being executed, all the 3 processes will be entered, because the arrival time is 1, 2 and 3 for the process P1, 2 and 3, right? So when P0 is being executed, the remaining 3 processes would have come. So which will be taken the first? See, the execution time 3 is least, so 3 will be taken the first. And what's the service time? 5, because after P0, P1 will be taken, right? So after P1 is over, what about the next process? See, the next 2 execution times 8 and 6, so which is minimum 6. Okay, so 6 will be taken the next. Okay, so here the service time is 8, because P0 and P1 will be executed. So 5 plus 3, it is 8. So 8 is the service time of P3. So after P3, P2 will be executed. So what is the service time? 5 plus 3 plus 6, it is 14. Okay, so P2 is executed. So the order of execution is P0, P1, P3 and P2, right? So the same way we calculate the waiting time. Okay, service time minus arrival time, and we take up the average. Here it is 5.25, right? So the next thing is priority based scheduling. Prioritizing is based on priority of the processes based on memory requirements, time requirements, or any other resource requirements. According to the resources available and according to the time available in the process CPU, the priority will be given. Okay, so this is a non-preemptive algorithm, right? So the same example we have. See, one more column is there, which is priority. Priority is for P0 it is 1, for P1 it is 2, for P2 1, for P3 3. Okay, so as always, P0 will be executed the first. So no other process will be preceding P0. So because that is the first process, that will be taken first. Okay. So P0 will be executed first with no service time. It is 0, right? So when P0 is being executed, 1, 2, 3, P1, P2, P3 would have come. Right. What about their priorities? P3 has the highest priority. So that will be taken the second. Okay. So after P0, P3 will be executed. See the service time, it is 5, which is equal to the execution of P0. Okay. So after executing P3, what will be taken next? See, P1 has priority 2 and P2 has priority 1. So P1 will be taken. Okay. So see the service time. See the service time, it is 11, which is 5 plus 6. The execution times of P0 and P3, 5 plus 6. So service time of P1 is 11. So after P1, P2 will be taken, which has the priority 1. So it is 14. Right? So the order of execution is P0, P3, P1 and P2. Okay. So depending on this example, we calculate the average waiting time. Here it is 6, the same way. Service time minus arrival time divided by 4. Right. So the next type, fourth type of algorithm is shortest remaining time. Shortest remaining time is to reduce the process waiting time. We see process remaining time. Okay. So shortest remaining time is the preemptive version of shortest job first algorithm, or shortest job next algorithm. Okay. There it was non-preemptive, and here it is preemptive. So preemptive version of shortest job first is called as shortest remaining time. That's it. Then here it is a very important algorithm, which is round robin. Round robin is simply when n processes are there, every process will be allocated an equal time quantum. Okay. So every process, whatever priority it would be, whatever execution it would, or execution time it would be, the process will be allocated the processor time only for the particular time quantum, and the time quantum is equal to all the processes. I say again. Okay. Right. So see here, you have to patiently see this algorithm, see this example. The same problem we take. Okay. P0, P1, P2, P3. Okay. See, P0 is taken first. Okay. So the quantum is 3. See the top, quantum is 3. So the running service time of, execution time of P0 is 5, right? So first 3 quantum P0 will be executed. So the next time quantum will be given to P1. That is, for 3 minutes P0 will be given. The 3 minutes over, if the 3 minutes is over, it will be automatically allocated to P1. And P1 will be executing it for 3 minutes. It will be using the processor for 3 minutes. And the next 3 minutes will be given to P2. Okay, that will be executing processor for another 3 minutes, and so on. Right? So, see, after actually the execution time of P0 is 5, but P0 is executing only for 3 minutes. So the remaining 2 minutes will be executed after P3. Right? So first P0, P1, P2, P3, all the process will be using the processor for the time quantum 3. When P3 is over, P0 comes again, and it will use the processor for its remaining time of execution, which is 2. Actually, the execution time of P0 is 5, right? So first 3 minutes it is over in the first batch itself. When the next batch starts, it will use the remaining 2 minutes of processor time. Okay. So after P0, actually P1 has to come, but P1 has already finished, because the execution time of P1 is 3. It is over in the first batch itself. So P1 is over, then P2 comes. Okay. So what about P2? P2's processing time is 8. Okay. So so 5 is remaining. Already 3 is over, so 5 is remaining. So in that 5, P2 is using it for 3 minutes. So for P2, another 2 minutes is remaining. So that will be used at last after P3. Okay. So you have to patiently see this. The same way we calculate the waiting time, service time minus arrival time. See here, the average waiting time is 8.5. Okay. So this is an important question which will be asked for 5 marks. Right. Then multi-level queue scheduling. Multi-level queue scheduling is priority is given to jobs depending on different requirements. For example, CPU bound jobs can be scheduled in one queue and IO bound jobs will be scheduled in another queue, right? So this different the processes of different requirements will be scheduled in different queues. Okay, so every queue is given one level of priority. Okay, so this is called as multi-level queue. Okay, so when the jobs are taken, the first level, one job in the first level will be taken, and when that job is over, then the first job in the second level will be taken. Okay, when that is over, the first job in the third level will be taken, and so on. So if there are three levels, the first job in the third level, when it is over, the first job in the third level is over, again the second job in the first level will be taken. Okay, so that way it is executed. So that is called multi-level queues scheduling, and I hope you have understood all. We have seen first come first serve, shorter job first, then round robin. Okay, so everything we saw, I hope you understand. You kindly study this, take notes, and be benefited. Thank you.